In this video, I'm going to talk about the most common error in mathematics, applying powers and roots over the four basic arithmetic operations. Let's take a look at the following four equations. There are many people who think that the first two are correct. There are many variations of these two equations. For example, some people might think that sine theta plus cosine theta all squared is the same as sine squared theta plus cosine squared theta. Some other people might think that 4x squared minus 9 can be factored into 2x minus 3 all squared. Unfortunately, these two equations are entirely wrong. I'm not saying that these two equations will never be right. For example, if you take y being 0, then x plus 0 squared is x squared, and x squared plus 0 squared is also x squared. So occasionally they are correct, but in general, for other values of x and y, they are most likely wrong. For example, 2 plus 3 all squared should be 5 squared. 2 squared plus 3 squared should be 4 plus 9, which is 13. Because 5 squared is not equal to 13, we should know that 2 plus 3 all squared is not the same as 2 squared plus 3 squared. Many people thought that the last two are wrong, but actually they are perfectly right. For example, if I want to calculate 9 times 16, I can first think of 9 as 3 squared, 16 as 4 squared. And because of these equations, I can rewrite this as 3 times 4 all squared. That means 12 squared. Everybody remember that 12 squared is 144. So we get 9 times 16 is equal to 144. Another example is 36 times 25. Because 36 is 6 squared and 25 is 5 squared, I can rewrite that as 6 times 5 all squared, which is 30 squared, which is 900. Or we can also rewrite 8x cubed over 27 as 2x over 3 all cubed. This is because 8 is 2 cubed, 27 is 3 cubed, and both of these equations are correct even when we replace the power 2 by other powers, such as 3. How about equations involving square roots? It turns out that if x and y are representing general real numbers, then all four equations are wrong. The first two equations are wrong for a similar reasoning as before. We just cannot split up the square root sign over addition or subtraction. For example, if we have square root of 3 squared plus 4 squared, this is equal to square root of 25. However, if we try to split it up and get square root of 3 squared plus the square root of 4 squared, we would actually get 3 plus 4. This is 5, while this is 7, and therefore they are actually not equal to each other. As for the next two, they are almost correct, except that we have to put in the extra condition x and y are both non-negative. Why? This is because for general real number a, if we first square it and then take the square root, we will actually get the absolute value of a, but not just a. For example, if we have negative 2 squared and then take the square root, we will have 4 inside the square root because negative 2 squared is positive, and square root of 4 is positive 2. Therefore, you do not get back negative 2, but the absolute value of negative 2. However, these two equalities are always true. So how do I remember what is right and what is wrong? Of course, A lot of practice will help, but there is another way to do it as well. We all have learned the order of operations. In the bottom is plus and minus. In the middle is multiplication and division. And in the top is power and root. We all know that multiplication and division can distribute over addition and subtraction. Similarly, power and root can split over multiplication and division. What do I mean? Let's take a look. X times y can go first before you square, or you can first square each number before you multiply them. X squared and y squared can be multiplied together before you take the square root, or you can take the square root of each number before you multiply them. The same thing happens for division. You can first divide the numbers before you square it, or you can first square each number before you divide them. Square root is the same. You can split the square root over division by first taking the square root and then divide the two numbers. However, power and root cannot distribute over plus or minus because power and root are two layers above plus and minus, but not just one layer. In other words, if you have two numbers adding up first before you square it, you cannot calculate it by first squaring each number and then add them. Similarly, if you have two numbers adding up together before you take the square root, you cannot calculate it by first taking the square root of each number and then add them up. Same thing for subtraction. None of these four equations will work in general. I hope that this video helps you clarify when you can split powers and roots over the four basic operations. If you like this video, please subscribe our channel and we'll learn more fun math together. Thank you for watching.